Awesome. So, thank you. I'm Ryan, Heptio as well. And I'm going to talk a little bit today about running Elasticsearch on Kubernetes. There's a lot of things that need to be considered. I do not have a silver bullet for you guys, but we're going to talk through a little bit of everything to understand sort of the state of where the systems are today and work to be done. So first of all, quick show of hands. Who knows about Elasticsearch? Cool. Who's actively using it? And who's using it on Kubernetes right now? Okay, so the hands continue to dwindle as what I was expecting. So Elasticsearch is a distributed full-text search engine. It also does analytics and aggregations. If you've done the ELK stack or the Elastic stack before, the thing behind the pretty graphs that Kibana builds is Elasticsearch. Now, it is a distributed system, and because of that, there's a lot of factors that need to come into play. So before I can get into the considerations that we need to think about specifically on Kubernetes, I'm going to give just a quick, 10 to 12 minute dive on the big pieces behind the scenes of Elasticsearch and how they're going to affect it when we go into Kubernetes. So, let's whiteboard a little bit. Are you going to be able to get this? Okay, perfect. Let's do that. So, in Elasticsearch, we have to put our data somewhere, and it's behind here. So first of all, it's fairly trivial to run one instance or node of Elasticsearch in Kubernetes. It's no different than like running a MySQL instance in Kubernetes. It's not that exciting. But when it starts to get exciting, right, is when we have more than one node. And nodes in Elasticsearch are a running instance, so one container, node essentially, one pod. And nodes work together to form a cluster. And when nodes are part of the same cluster, they share two main responsibilities. One is to store, search, and index your data, probably the fairly obvious one. And the second piece is that it answers API requests. So when we send those API requests to Elasticsearch to say index a document or search, we can hit any of these nodes. Now the important part and the crux in the Kubernetes world here, right, is the storage of this. Now when we put data into Elasticsearch, we put it inside of an index. And an index conceptually wraps an entire cluster. So we have to put our data, our documents, into something. We'll use the logging example because it's a classic one. So what is a document? A document is one line on a log file. If we were an e-commerce website, a document would be one product from our e-commerce. But this index is just like a logical thing. It doesn't actually hold data. The pieces and parts in Elasticsearch that hold the data are called shards. And by default, when we make a new index in Elasticsearch, our index gets 5 shards. These shards are running instances of Apache Lucene. So basically, that's how Elasticsearch gets its distributed nature. We basically crank out multiple engines of Lucene. And these are what actually hold our data. So if I go and take, let's say, 100 documents, and I put them into this index, the data is going to be distributed across our index and across these shards. It's not binary distributed or block or file-based. It's document-based. So what's going to happen is, assuming perfectly even distribution of our IDs, 20 documents will go here on this shard, 20 on here, 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 and here, for a total of 100 documents in our index. So these are the shards. Our data is distributed across these. And there's actually two kinds of shards in Elasticsearch. The second kind of shard is a replica shard. And these hold. We have, by default, when we create a new index, we get 1 replica per primary for a total of 5. So here, and like so. And what do these replicas do? Well, replicas exist primarily for two reasons. One is high availability. The same 20 documents that are on this shard 0 are also over here on this shard 0. So we gain that if we lost this node, it went down, either intentionally or accidentally. No worries, we have a copy of the data over here. We can continue on our way, both searching and indexing. These replicas also give us read throughput. I'm not going to go into the details of that, only because it's a little bit longer discussion and it's not relevant for our Kubernetes topic. But the HA certainly is. What happens is if we lost this node, Elasticsearch would promote this replica, wrong color, would promote this replica to a primary. And then it would find other nodes in the cluster to go rebuild the replica on that we lost, because we lost a replica 0 when we promoted this one to a primary. Now, you might also note that I conveniently drew the numbers on the boxes up here. One of the most basic rules in Elasticsearch is to never put more than one shard ID for an index on the same node. Putting the replica shard 0 over here does not help us at all. We lose this node, we lose both copies. Now the 2-node cluster is not very interesting because basically we get a copy of our data everywhere. 3-node clusters and larger tend to get a little bit more interesting, as you can see. I'm sorry that it's so low. But basically we would maybe take this guy here. It would be down here, and maybe a replica from over here, like a 1. And it would be down here. Now, this is the fundamental nature of Elasticsearch. Each node is storing data on its either local storage or on its mountain storage. So the real question comes along when we start to drop nodes, remove them, etc. But before I go into all of that, are there any questions in regards to this? Hopefully for those of you intimately familiar with Elasticsearch, this hits home, and maybe for those of you who tangentially have used it, this maybe sheds a little bit more light. Yes?
As someone who used Elasticsearch for quite a while, that was a very good explanation.
Oh, awesome, thank you. Any others? Cool, all right. So now that we have that.
One question.
Yes?
Regarding primary replicas versus, or primaries versus replica shards.
Yes, the definition of replica here is much different than replica sets in
For sure.
Kubernetes.
Like, what is the sort of asymmetry between primary and replicas? Are the primaries serving requests in a different way?
No,
Like, what?
good. Great question. Let me use it with an example of what happens when we index a document. When we index these 100 documents into here, it first goes to the 20 documents that need to be routed to this shard. It goes to the primary first, regardless of whether we have 0 replicas or 20 replicas. 20 is an insanely large number, by the way. And what happens here is we deserialize the JSON. We take all the fields for your JSON document, we pull them apart. If it's full text, we break it into individual words. And then we build the inverted index, the data structure that makes search possible, for every field in your document. For all of those inverted indices that we build, we also then need to compress it and write those data structures to disk. That's all the work that's happening. There's a bunch of other side work and other side data structures we build for performance for non-full text search, but that's the general concept. Once it has been successfully indexed here, then we repeat all of that work on any of the replicas as well. So over here, that same operations happen over here.
Afterwards, it's not very
Once it's successfully done on the replica. Okay, so the replica is I'm pointing at primary. The primary is the gatekeeper for write operations. And it's primarily so that, like, what if we have contention of multiple writes coming in for the same document ID? We need some type of order gatekeeper there, and that is the primary. Yeah, and we assume that if we were successfully able to index on the primary, then any failures that might have occurred on 0 or more replicas is not the fault of you, because you fed us good data, we were able to index it here. It's the fault of a failed disk, network card, GC baking stuff the world or whatever on the rest of it. Yeah. Is that where you're going?
Yeah.
Okay, cool. All right, awesome. Now that we know about this, let's jump back over into Kubernetes land. So there's been some help that can help get us closer to this. Stateful sets came out in Kubernetes because we could mount persistent volumes and make a claim for every deployment and every pod that's running a Elasticsearch node, but we can't just sort of like randomly come through and write these two quickly. If we just shut two of them down at the exact same time, or if we shut them down too quickly, basically Elasticsearch's Superman mode won't kick in fast enough to handle the fact that we're dropping stuff in and out. So stateful sets basically give us unique identifiers. They take the form of the stateful set name, which is arbitrary, whatever we set, and then ordinal, so 0, 1, 2, 3. So if I had a 3-node cluster, I might have Elasticsearch-0 dot my service, and then the rest of my cluster's namespace. And we sort of have this, and there's guarantees. For example, we won't start up Elasticsearch-0, Elasticsearch-1 until Elasticsearch-0 is up and running successfully. And likewise, when we're tearing stuff down, we tear stuff down in order as well. So these can really help us when we're talking about gracefully bringing stuff that needs persistence up and down. And also, these leverage that same notion of is it ready or not. We have to leverage the liveliness and readiness probes because the pod might be up, but Elasticsearch may not be ready to service requests yet. There's all these things, there's your transaction logs and everything that we do when we start up. And it might take us, if we have a backlog of that, maybe a good 10 minutes or so to chew through that thing. We wouldn't be able to service requests until. So there's stateful sets help us. But what's really going to help us to make Elasticsearch and other persistence engines like this successful in Kubernetes are operators. Who here knows about operators in Kubernetes? Okay, cool. Awesome. Has anybody written one? Extremely awesome. All right. So operators essentially tend to be a combination of a third-party resource, which is being renamed to a custom resource definition. Same sort of stuff, but being renamed. Basically, we can make our own basically objects or resources that get stored in that etcd. We can define them. I like to think of them as a DSL. And to basically glue together a bunch of pieces and make it simpler than having to juggle all the different stuff we need to do for a complex application like this. And then it also gets paired with a custom controller that basically can override the default behavior of Kubernetes, where like when we do rolling deployments, which says we're going to add one, and then we're going to, if we do an upgrade, we might add one, take one away, add one, take one away, and so on and so forth. To be basically specific to the application's requirements. So this is our way to basically write custom code, extend Kubernetes, and say, I'm going to put the business logic that's necessary to run something like Elasticsearch, like Postgres, like your Mongo, etc., in here, and have when Kubernetes goes to schedule and tear down and scale up things, that it can do it intelligently for the system that's behind it. Everyone good on those? Awesome. So there's been some work done in the community so far. One such operator is by Steve Sloka. It's called the Elasticsearch operator. It's on GitHub, and I'm going to demo it real quick here. And then there's also been some work done by the JetStack folks, and theirs is, they have a different name, it's the Elasticsearch Navigator. It's a little bit more of a superset. It's intended to be a collection of a lot of operators, and one of their current inside of a framework, and they chose to be one of their first implementations with Elasticsearch. I'm sort of actively been talking about these with these folks in the last couple days and weeks, so hopefully we're going to see a lot of progress here. So let's go take a look at some of these. Okay. So I'm going to make this bigger. I'm also going to try to use the Kubernetes UI a little bit just because of our screen resolution here. I think that might be a little bit easier than... Yes?
We lost a Chromecast.
We did. I think it's the number of devices on the Wi-Fi. Maybe. Let's try again.
You're in a different Wi-Fi.
Good? Okay. Well, I was running some... Oh, we're doing better. Okay. So here we are. This is a cluster running with the Heptio's AWS Quick Start. So I have just something other than demoing on my local machine, just because I wanted to be exciting and brave, but also wanted to show not just one machine. So it is, we do have a few nodes here running, 4 nodes up in our Quick Start in AWS, but everything else is empty, no deployments, no controllers running, no jobs, etc., no pods. And also if we go and look, let me make this bigger as well. Let me make this a little bit nicer as well. Oh. And we'll see that there are no current third-party resources registered in Kubernetes. So we have a controller definition. Is this sort of readable?
No, very.
Okay. Go big or go home, maybe? I'm going to try this one more time before I... Oh, it didn't save, sorry, it didn't save my preference. Better, okay. My apologies. This is essentially registering the Elasticsearch operator itself. So this is going to be a pod that's running in the cluster. And it's going to do 2 things. First, it's going to check to see if a third-party resource is there. If it's not, it's going to create one. And then it's going to have, essentially, this pod that's going to stay running and try to manage an Elasticsearch cluster for us. So, okay. Hopefully, maybe this might be easier. Well, let's go back here. Now let's do... we should hopefully have a third-party resource register. Now we do. And this essentially is now going to, if we make, put up a new YAML file with a type of Elasticsearch cluster, it will know what to do with it. And then we also should have, we now have the Elasticsearch operator running. Okay, so now let's go and look at an example cluster that we could start. So if we notice here, we have the kind of object this is Elasticsearch cluster. This is something that was, if we tried to put this up prior to registering third-party resource, Kubernetes would not know what to do with it. But we now have that third-party registered resource, and it basically defines this spec. So now we basically, as the author of this operator, Steve said, hey, I need the following things. I need to tell me, hey, what image should I use for Elasticsearch? What's the number of client nodes, master nodes, data replicas I want? What zone should I run? What should I have for the spec? What are my Java options? All the stuff that's specific to Elasticsearch in this scenario. So let's go ahead and run this thing, speccing out the memory as well. Okay, so now that we have made this, let's do it from here. We have our deployments are starting up, our client, our master node. So basically it's orchestrating all the pieces we need for this much larger, complex deployment. We have stateful set being created. It's waiting for the volumes to be bound and come up. And when it's done, we'll see that we're going to see these incrementing as we go through. We have a 2-0, and then it's running, and now we're going to be initializing the 1, and then when this one's finished, it will have the 2. So this is basically a rough example of one of the operators. I didn't have time to do them all, but to sort of give you a flair of the kind of stuff that we do with the operators. Any questions before I move on to now the tough stuff that still needs to be thought about and everything?
What about that
Yep.
needed to be a stateful set versus something stateless?
Why is it stateful set?
Yeah, assuming you could do like a persistent volume claim. Like I guess I'm just gapping on why does that need to be a stateful set versus something else?
Well, the stateful set is sort of, it provides those features of like the.
Can you repeat the question? I think probably.
Sure.
Yes.
The question was, in this particular scenario, the operator implemented the solution using stateful sets as opposed to just a regular persistent volume and persistent volume claim. And it really goes into, because we're dealing with a distributed system like this, an Elasticsearch, where we think about all this data spread out, we want it to do it in a carefully ordered manner and not drop a lot at once or randomly drop them. So in the 0 through 1 manner, in something like this, most people running Elasticsearch don't scale it down. You usually have a minimum sort of number of it running, and you might scale it up a little bit.
Minimum 3.
Minimum 3 usually is a very classic for your data nodes, etc. So sort of have this ordinal numbered ones and a little bit more name to it is helpful for this scenario. And then also, I'm not intimately familiar yet with the Kubernetes roadmap, but most likely stateful sets will get new sets of features to help stuff like this even more, so then it'll help with that too.
Did
Awesome
the operator
questions.
manage a service or something in front of it?
Pardon?
Did the operator manage a service or something?
There-
You probably flipped through it, but I didn't.
There is a service in front of it. I need to change my key now. There's actually, I think, 2 or 3 services. One for the port 9200, which is the API of Elasticsearch, and another for the node-to-node communication, port 9300.
Perfect.
Yep.
Just wanted to know that's managed.
Sure. Okay. Did we get better? Yay, they're all up. Okay, good. And hopefully if we go back to here, yes, no errors yet. So we're all up. Okay, so now that we know these exist, and there's a few of them, you can go see what's out there, or see which one you like a little bit better, etc. What are the kinds of things we need to worry about and implement in these custom logic, besides just gluing all that up together? Well, one is shard awareness. So this is the notion. Elasticsearch doesn't know that this node and this node might be running on the same rack, or the same VM, the same node in Kubernetes, or the same zone in EC2, etc. So we wouldn't want it to put a replica over here, because if a whole rack fails, we're going to fail both of these nodes at the same time. So we can make the operator be aware of this and set up a feature in Elastic called zone awareness, which basically tells Elasticsearch these nodes all are in the same place where there's a potential they might go down at once. So put the replica somewhere else. That's one thing that can really help us. Rolling restarts. Of those of you who rose your hand that you said you use Elasticsearch, who here restarts Elasticsearch by just doing, if you stalled with RPM, service Elasticsearch restart on your nodes? Okay. Does anybody actually disable shard allocation, shut it down? Awesome, folks. All right. So basically, if we just restart a node in Elasticsearch, Elasticsearch doesn't know that we intentionally brought it down. So it's going to first promote the replicas for the lost primaries to a primary. Then it's going to wait 60 seconds. And if the shards haven't come back into the cluster, it is going to rebuild them. That's a lot of thrash and a lot of work if it's going to be back quickly. Those of you who don't do this, you might find that your startup times of Elasticsearch are a lot longer than what you would like them to be. So we need to do this whole thing of we disable shard allocation which is an API call to Elasticsearch itself that says, don't make new shards. Then we restart a node. Then we monitor the Elasticsearch API, make sure it's back in the cluster, wait for the cluster to go yellow, re-enable shard allocation, wait for the cluster to go green, and then repeat all of those steps for every node. This ensures that we don't make a lot of thrashing and we don't waste a lot of CPU cycles negatively affecting your search performance while you're trying to do maintenance on the cluster. This is kind of logic we wanted to put in Operator as well. Custom liveness probes and readiness probes, we want to actually hit the APIs on Elasticsearch to make sure it's up, running, ready, green, etc. for that node before we move on. Node attributes. Node attributes are sort of like your labels in Kubernetes, where you can label all your pods and your deployments. The nodes in Elasticsearch can have labels on them as well. Anybody here run an Elasticsearch cluster with a non-homogeneous set of machines? So maybe some of them SSDs and some of them spinning disks. This is common because we all sometimes money just doesn't grow on trees and we can't buy it all to be super fast. Well, in this scenario, the labels on these nodes we can programmatically do based upon the type of storage, the zones they're in, settings they're in, etc. So why not automatically set that with the operator? And then interpod anti-affinity. So ideally, for systems like this, we might want to say, okay, if there is a pod running Elasticsearch on a worker node of Kubernetes, let's not place another one on there. But another one for a different cluster, if we have multiple Elasticsearch clusters, I know the terms are a little overloaded, might be okay. So those kinds of things, in my opinion, I like to see these things sort of like the sensible defaults just be enabled out of the box, but all of us would have the control to disable them or tweak them accordingly. So not all of these are solved yet, but we'll get there hopefully. And that is essentially 802. We're hopefully okay. What I had to plan to talk for today, but I'll welcome any questions. Yeah?
So there's improvements you're putting back in the operator process? Yes.
So those two operators are not authored by me. They're authored by the community. I would love I spent 2 years at Elastic, so I'm intimately familiar there. I would love to see Elastic, the company as well, make an official operator, or maybe a combination of the two that we have here, then contribute and be taken over by Elasticsearch. I don't really know how that is going to play out, but I'm in contact with the JetStack folks and Steve from UPMC, and hopefully we're going to figure out a good way to do that. Yeah?
I think it was the JetStack repository that said something about database as a service, and I guess one of them is Elasticsearch. Are there others that they're looking at or
yeah, it's
or otherwise?
I haven't talked in that level of detail with them yet. I think they're looking. This looks like Couchbase coming soon. It says.
Okay, so.
But I don't know the extent of that yet. Yes.
Is it possible to define an invalid Elasticsearch cluster in that third-party resource document?
Question was, is it valid to define an invalid Elasticsearch cluster in that custom resource definition? No, sorry, third-party resource, which will eventually be that. Yes, you could. For example, if I got my limits wrong, like the amount of heap memory, let's say I'm grabbing 4 gig of heap memory, but I put my limits on the Kubernetes resource at like 2 gig. Elasticsearch is going to boot up. It's going to try to grab 2 gig right from the OS to populate, warm the heap, and memory killer is going to happen, and your pod's going to die. So things like that.
Basically, what I'm wondering about is, does the operator model give you a way of? I'm trying to think about how the operator model fits with like a mission controller. Like, is there a way for the operator to reject a modification of the third-party resource, or do you just do that with the events?
That is basically one of those things. It's up to how detailed and how much work you want to put into it.
Okay.
Yeah. So it's sort of one of those things, like anything can be possible. It's just a matter of to what extent you feel it's worthwhile to code that in. Yeah. Good questions. There, and then we'll go here.
What is the recommended storage for Elasticsearch? You mentioned you run in AWS. I use an EBS. So what other alternatives?
Yeah, so the question was, what is recommended storage for Elasticsearch? The answer is always local disk is king, to be honest. The less dependencies you can have over the wire and attached, the better. But when we're working within the confines of Kubernetes and the whole pods coming up and down and nodes flying around, it's a little bit harder to use locally mounted storage. I mean, it's possible, just not an ideal implementation yet. So EBS is it in EC2. If you are using it, you want to make sure you use provision IOPS to guarantee fast speed. Otherwise, you'll get unpredictable results. Yes, sir.
So this is an example of a third-party operator that would allow one to more easily run an application within Kubernetes. So when you're making this operator, how long does it take you to make a good operator? Because somebody's going to evaluate these operators to see if this is the best way to run my application within the cluster.
Okay, good question. The question I'm going to just paraphrase real quick is, how long does it take to write a good operator? And that depends on your definition of good is. And what I mean by that is something as complex as this, it might take you a lot longer. Also is probably how generic you want to make it. So if you want to be like the end-all be-all, like default go-to operator for a specific technology stack, then you're probably going to invest a lot of time to make it pretty turnkey and a lot of features abstracted into your custom resource definition. If you don't care as much about that, then you can take a lot of shortcuts and assumptions, and it could take a lot shorter. It's about the best I can give you. Yeah. I think we maybe one or two more and then call it, Matt?
Yeah, that works.
Oh, there you are. Okay. We'll go here and then here.
Can you talk, even in general terms, about some production deployments you've seen of Elastic on Kubernetes? What went well, what did not go well?
Can I defer to Mr. Rosser? Only because I have not seen nearly, I'm much greener to Kubernetes than Rosser.
So most of the Elasticsearch systems that I've got running on Kubernetes are primarily focused for log aggregation for the Kubernetes cluster, and then the applications that are deployed on top of that. However, I have a previous client that is using Elasticsearch for their application stack too, and that is also running on Kubernetes. When we built and deployed that, these operators were not nearly as advanced as they were, so we were manually managing the stateful sets for the data nodes, the masters, and the clients, and eventually managing everything. I imagine they will move their way towards operators as the operators continue to advance. Like that's the operator paradigm, I think, is the right direction. And I did a talk at CoreOS Fest on like, the state of staging containers, and like I'm so excited Ryan did this talk because it's so much more like hands-on in depth with how it actually works. But I think the operator paradigm is the right place to go. It's where Kubernetes, in terms of as a platform, provides the extensibility with the APIs and the third-party resource objects. And it means you can build these higher-level primitives like these operators to handle very complex systems. You do have to write some code to do it, or find. I agree with Ryan that I would love for each of the database providers to write their own operator for Kubernetes. That's the deployment mechanism, not an RPM in some docs, but give us a Kubernetes operator and we can all manage that database as a service.
I'll crack one of my very rare cellared beers like 2 years from now or a year and a half from now, hopefully when that is, I can rewind and watch this and say, yes, we're there. Yes.
So for mission critical, highly available applications, Elasticsearch, would we still use operators to align the Elasticsearch nodes with the provider, the cloud provider, full domain, for example? Or these are two different operators, one for using labels and the other one would be using the operator?
What was the one for using the operator and one for using?
So today, in order to align the full domains with the different Kubernetes nodes, we use the labels, the Kubernetes labels. But if we want to have this transparent across the application and the orchestrator as well as the cloud provider, would that be the operator or?
So the question is about like basically the interaction of labels in comparison to operator. They're going to work hand in hand. So like I would envision in a way like clusters brought up by my operator are always going to get the following labels stamped on them anyway, like operator name or this or that, like just so I can do that kind of mechanics. But in my operator DSL, I would probably also like say, here's a spot where you can supply me other labels, and then I'll pass them through, I being the operator, will pass them through and place them onto the deployment services, etc. So you could still say, I spun up 3 clusters with the operator, but for this one, place this label on these ones, and so on and so forth. So you can still do your overall management. So I would say you'd want a combination of the 2. All right. Well, thank you so much.